Our goal is to analyze convergence and divergence of the following series, and we're going to use comparison test because of n factorial. From algebra, remember that zero factorial is 1. 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. If you continue this process, n factorial can be written as n times n minus 1 times n minus 2 dot 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 3 times 2 times 1. In the general term here, you have n factorial divided by n to the n. So let us do the division. N factorial divided by n to the n. What is this guy? This guy can be written as, if you rearrange this, the multiplication can be written as 1 times 2 times 3 dot 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 times n minus 2 n minus 1 times n. So your numerator is 1 times 2 times 3 times n minus 1 times n divided by n to the n, which is the multiplication of n by itself n times n times n times n dot 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 n times n. So basically, you can get rid of the last term here, n and n. And you can start comparing these with numbers. Why is that? For example, n minus 1 divided by n. Take a look. If I take n minus 1 divided by n, since from algebra, n minus 1 is less than n, if I flip this, or if you divide by n, n minus 1 over n is less than 1. So this quantity indeed is less than 1. What about n minus 2 and n? The previous fraction. The same process. N minus 2 divided by n is less than 1. Since n minus 2 is less than n, n minus 2 divided by n is less than 1. So the previous fraction here is also less than 1. You can continue this process. When you get to 3 over n, it is indeed less than 1. Why is that? Again, since 3 is less than n, 3 over n is less than 1. All right. What about the first two terms? The first two terms, they're going to stay the same for now. We can indeed say that n factorial divided by n to the n, so n factorial divided by n to the n is indeed less than, equals to 1 over n times 2 over n times 1, 1, 1, 1. 1 times 1 times 1 and 1. So take a look. N factorial divided by n to the n is less than, equals to 2 divided by n squared. Very good. So that's why we are using comparison test, because now you can compare n factorial divided by n to the n by 2 over n to the n. In comparison test, remember that if an is less than bn and the larger series is convergent, you can for sure conclude that the smaller series is convergent as well. But let us take a look at our comparison test here. Here I have on the right-hand side the summation of 2 divided by n squared, which is basically a p-series. And p is equal to 2 more than 1. This is your p. So this is a convergent series. So by comparison test, the series on the left-hand side, the smaller series, must be convergent as well. N factorial divided by n to the n is also convergent by comparison test. So whenever you see n factorial, try to go back to algebra and try to make it a little bit simpler by breaking it down into smaller pieces. For example, here from algebra, we know that n factorial is the multiplication of 1 times 2 times 3, and in the other way around, you can write it as n times n minus 1 times n minus 2, and so on. And then basic algebra says n minus 1 is less than n, no doubt there, because of the domain that we're working with. So if you divide both sides by n, n minus 1 divided by n is less than 1. So basically, you can find an upper bound for n factorial divided by n to the n. This is upper bound. So now that you found the upper bound, you can compare n factorial divided by n to the n by 2 divided by n squared. This is comparison test. Comparison test says if the larger series is convergent, the smaller series must be convergent as well. But here we have a p-series. For this p-series, n is equal to 2, which is more than 1. So this is a convergent series. So indeed, the smaller series must be convergent as well. So we just showed that by using basic algebra, and p-series convergence of the larger series guarantee the convergence of the smaller series as well.